Hey everyone, welcome back to SAT Practice. In this video, we're going to continue where we left off last time, where we're looking at the official SAT study guide from 2018, Practice Test 1, Section 3. This is the first math section. Before we get started, I just wanted to reiterate some of the most important points that we covered in our last video. The most salient point is that of unit analysis. So unit analysis is really important because it gives you context for a numerical quantity. This is a very easy way to raise your score by simply keeping track of the units for each numerical quantity you encounter. We're going to see this right away on our first problem, but it's a pattern that shows up again and again. So I'll reiterate this as we go along, but as you work through these problems, make sure you account for this in your own practice. So let's get started. We're looking at problem 6 now. We're told that a pediatrician uses the model above. This model is H equals 3a plus 28.6 to estimate the height H of a boy in inches in terms of the boy's age A in years between the ages of 2 and 5. So let's write out some information. So H represents height, and it has units of inches. And A represents age, and it has units of years. And we're also told that A is between 2 and 5. And now we're asked so based on this model, what is the estimated increase in inches of a boy's height each year? So if you can't see the answer to this right away, that's okay. The way to think about this, at least, well, one way to think about this is to give yourself a graph, right? So let's draw this out for ourselves. We have A as our input, H as our output. We're looking specifically for the values between 2 and 5. So at 2, our height is going to be 3 times 2 is 6. 6 plus 38.6 is 34.6. And then our height increases by 3 inches each year until we reach until we reach the end of where this model is valid. So we were told here that our height changes. So as we were constructing this graph, we recognize that our height changes by 3 inches each year. So you notice that I added the units associated with my slope, which is inches per year. And if we look back on the problem, this is exactly what we're after, right? The slope represents the increase in inches of the boy's height each year. So our answer in this case is A. And just as an aside, in general, the slope represents the change in your output. So I'll write this. So M is usually how we demark our slope. So M, our slope, is our change in our output. So Y normally represents your output over your change in your input, and X normally represents your input. Now, of course, these are sort of template variables, right? You can replace this with whatever makes sense for the in the context of the problem that you're studying. But this is this is important to recognize that this is the significance of the slope. And you should also remember that when you have units associated with these quantities, if you carry those units, you'll understand at an intuitive level what the slope is telling you. And oftentimes these kinds of questions in the SAT are asking for this kind of insight. So let's move on to problem 7 now. So in problem 7, we're given this expression M equals R over 1200. Means 1 plus R over 1200 to the nth power over 1 plus R over 1200 to the nth power minus 1 times P. So just for our mathematical culture, let's say, we should try to understand what the different quantities in this equation are. So M is our monthly payment for a loan of P. So this is our loan principal, where we're paying back the loan at R% annual interest over N months. So number of months. So our interest is given annually, but we're making our payments monthly. And this whole equation is basically telling us what the value of our monthly payment should be to pay off that loan within N months. And now what we're asked to do is find a function, or we're asked to find the equation which gives P in terms of M, R, and N. So let's look at what we have here, right? We have M as a function of N, R, and P, and the problem is asking for P as some function of N, R, and N. Right? So all we have to do is basically manipulate this equation such that we isolate for P. So you'll notice that if we look at this big chunk in the middle, right? So I'll highlight what I'm talking about. If we look at this boxed expression, right? This is a function of R and N, and they always come together, right? So let me clean things up a bit, and I'll say M is equal to A times P, where A is this term, right? Is this big monster right here? Is this expression, and we know that A is actually, I haven't written it, but it's actually a function of R and N. That's okay, right? We just know that simply means that as we vary R and N, the value of A will change. But nevertheless, we can rewrite this equation above like this, right? M is equal to A times P. So now if we want to solve for P, right, we can simply say P is equal to A inverse times M, or equivalently, right? Equivalently, we can say that P equal to M over A. So all we have to do is find the answer choice that follows this form, right? So let's have a look at our answer choices. If we can do this, then we can move on, right? If not, if something is off here, then we have to go back and try to do some simplification. But it's unlikely that we'll have to, because if we look back at our original problem, A was not simplified, right? This was A in its most simple form. So let's have a look at our answer choices here. So if you look at our first answer choice, this is actually P equals A times M, right? You see, it's the same coefficient written over here, where in fact we concluded that we needed the reciprocal of this coefficient. In fact, that's what you observe in answer choice B, right? B is this coefficient is the reciprocal of the coefficient from A. So in fact, our answer choice is B. Answer choices C and D are maybe they seem intuitively pleasing because they're so simple, but in fact they're omitting a lot of information. And so neither of those is the correct answer. They're just red herrings. So the correct answer here is B. And now we can move on to problem 8. In problem 8, we're told A over B is equal to 2. We're asked to find the value of 4B for A. So the nice thing about this problem is that because A over B is equal to 2, we can conclude that neither A nor B is equal to 0. And that's nice, because we can take reciprocals of this quantity without any qualms, right? If one of those, if one of A or B were 0, then we may run into a divide by 0 problem, and that's illegal, right? We can't divide something by 0. In this case, we don't have to worry about that, right? So if A over B is equal to 2, that implies that B over A is equal to 1/2, right? Now we're looking for 4B over A, which is simply 4 times this first quantity. So that must mean there's also 4 times this quantity, which is equal to 2. So in this case, our answer is C. So this problem is nothing other than recognizing that that what we're given is in one form, and we need to get it into another form, right? You could have solved for A, went through and substituted in for A here, and then eliminated. But that's, I personally find that to be a little bit more cumbersome and perhaps more work than you need, right? So try to make your life a little bit easy on the SAT, especially for somebody who struggles a little bit with time. Just think about, how can I take the quantity that I have and manipulate it in the simplest way to the quantity that I need, right? All right, so let's look at problem number 9. This is another example of a problem where we can leverage some insight to really reduce the amount of work we need to do. In problem 9, we're told that 3x plus 4y is equal to negative 23. Then we're told that 2y minus x is equal to negative 19. And we're asked to find the solution to this system of equations. So with a system of equations, a linear system of equations, you'll use either substitution, right, or elimination. But in either case, the first step is the same, where you'll solve for the value of one of your variables. And the reason I bring this up is because if we take a look at our answer choices, we can reduce the amount of work we have to do by being intelligent about which variable we solve for first. For example, if you solve for y first, right? If you found that y is equal to negative 2, well then you know your answer is A. If you solve for y and you get negative 8, then you know your answer is B. But if you solve for y and your answer is negative 6, then there's this ambiguity, right? Is the answer choice C or is it D? In order to resolve that ambiguity, you need to take your value of y, substitute or solve for the value of x, and then based on the value of x, you can resolve whether it's C or D. Instead, if you solve for x, you see that there's no overlap in your answer choices. So, for example, if you solve for x and you found that x is equal to 9, well then you know right away that your answer choice is D. There's no additional steps you need to take. On the other hand, if you can't do something like this, then you need to go back and solve for the second variable. But in this case, let's go ahead and try to apply the strategy, and we'll solve for x first. And I'm somebody who prefers to do elimination because I think in general it requires a little bit less algebraic manipulation, and it's easier, at least for me, to solve problems in this way. So we'll look at our first equation. Says 3x plus 4y is equal to negative 23. And now we can see that if we multiply our second equation by negative 2, right, so we'll get 2x minus 4y is equal to 38, right? We can eliminate our y's by adding the two equations. So we get 5x is equal to 15, which implies that x is equal to 3. So this implies that our answer choice is B, But since we're doing our practice, let's go back and actually substitute and solve for y just to make sure that this solution holds. So we'll look at the first equation, right? So 3 times 3 plus 4y is equal to negative 23. So this is 9. So 4y is equal to negative 32, which implies that y is equal to negative 8. Let's look at the second equation, just to be very, very thorough, right? So 2 times 3 minus 4y is equal to 38. 2 times 3 is 6, so negative 4y is equal to 32. Again, y is equal to negative 8. So both equations give us the same result, and we can be very confident that the answer is, in fact, B. Alright, let's take a look at problem number 10 now. So in problem 10, we're told that g of x is equal to ax squared plus 24. Here, a is a constant, and the other piece of information that we're told is that g of 4 is equal to 8. And we're asked to find the value of g of negative 4. So here's another opportunity to use some insight to reduce the amount of work we have to do. But if you don't do that, that's okay. You can still arrive at the right answer by following some simple steps, right? But you'll recognize that in the expression, in the information that we're given, if we were to substitute in 4 for x, we would get 16a plus 24. Similarly, if you substitute negative 4 for x, you would again get 16a plus 24. So you see that because this term is squared, it doesn't matter whether we have a positive x or a negative x. The answer is the same, right? We will get 8 either way. So just to kind of prove that out, right, we get, I'll just write this, not necessarily prove it out, but maybe make it more explicit. G of 4 is equal to 16a plus 24, right? G of negative 4 is also equal to 16a plus 24. That implies g of 4 is equal to g of negative 4, which is equal to 8. So our answer is A. As an aside, when a function has this property, so g of x, in our case, g of x will always be equal to g of negative x. And that's because g of x has this quadratic with no linear term. And so we have g of x is always going to be g of negative x. So it's going to look something like, something like either this or this. But the point is that it won't be shifted left or right, right? That won't happen for this type of function. And this is actually the definition of an even function. So if you saw right away that g of x is an even function, you could see that your answer would be A. On the other hand, if you didn't see that, that's okay. What you could do instead is solve. So we were told 16a plus 24. So remember, this is g of 4. And we're told that this is equal to 8. So you can solve for a. So we're told, so this would tell us that 16a is equal to negative 16, which implies that a is equal to negative 1. Then you can go back and substitute now. So g of negative 4, substitute in a where you had a variable before. You can say, well, this is now negative 1. And this is going to be negative 4 squared plus 24. So this is negative 16 plus 24, which is 8. So either way will give you the right answer, as it should, but one way is a little bit more work. So I would really encourage you to try to find these insights where you can, but you should also rest assured that if you don't see that right away, that's okay. There's a very systematic approach to solving all of these problems. Okay, so that's where I'll leave it for this video. We'll continue with the next 5 problems in the next video. See you then.